Hello, my name is Mike Sherwood-Smith, and this is another presentation in the series Languages in the Mind. And this time it's about understanding multimodal communication in mono and multilinguals. I'm talking about how we communicate with other humans, and I will be talking briefly about chimpanzees as well, but basically it's about how humans communicate with one another. Yes, certainly using language, but also using various other means like gestures, facial expressions, and a lot. And this has been the topic of much interest in research recently. One of the things that people working in multimodal communication like to stress is the fact that gestures and the like are not mere accompaniments to language, but actually enrich the communication and must be treated with more respect. I shall accordingly do so. So let's continue on, but first I'd just like to show you the URL, which is https cognitionframework.com. This will be repeated at the end, but there you will find much more about the Modular Cognition Framework and the various other topics that have been dealt with, and they're all on the multimedia page. Let's then proceed without much further ado to the overview. Okay, so there will be various sections in this presentation. The first one will be a short one, just to get straight what the relationship is between language on the one hand and communication on the other. Then I will have to look at the Modular Cognition Framework and how it views the mind, and it will be a selective review, as I warned you, so it won't contain all of the architecture, but enough for making some conclusions, and drawing some conclusions about multimodal communication, and hopefully casting some light on it. The MCF, as you know, can be used as a tool for interpreting data, right? It is one can generate hypotheses from it, but it's basically a tool for putting specific types of data into a larger context and giving them a richer interpretation. I'll have a little what might be regarded as a side in section 4, and this wasn't included in my previous talks, and that has to do with where we begin at birth, right? Just to make sure it's clear that these various cognitive systems that I'll be talking about that contribute to multimodal communication all have a particular status at birth, and that is significant for the understanding of what happens. And I will draw, in fact, 7 implications in the conclusion. Okay, so let's begin with the short first section, which is how are language and communication related. So what is language? People may say, well, of course we know what language is, but it's one of those terms which the moment you want it precisely defined, you find that people disagree. And there are various definitions of what a language is. So if I'm going to talk about language, I have to tell you what my definition is, or what definition I'm keeping to. Of course, it won't be a simple definition. Those are really not enough. Language is a system for connecting sound and meaning. That's a sort of linguistics 101 kind of statement. And it's true in a general sense, but there are other systems we use for connecting sound and meaning, so that's by no means a full and sufficient definition, nor is language a system of communication, because of course gestures and the like are also systems of communication. And thirdly, language is the way in which humans communicate. That gets closer to where we are, but the way, it's not the way, it's one of the ways in which humans communicate. So in other words, communication is one of several features of language and not the essential one. Not the essential one, says Chomsky, perhaps controversially for some, because he thinks that language the essential function of language is thought. But that statement can be reversed quite easily, so language is just one of several features of communication. Okay, so well, here are two humans and they are communicating, and as you see, one of the humans, the larger and apparently older one, is gesturing as well as talking. And indeed, human communication is typically multimodal. Language is often involved, but you'd be surprised that in many contexts, effective multimodal communication can often take place without the use of language. Okay, now let's go a little more deeply into the mind as seen from the Multi-Cognition Framework. And I'll try and be very selective, focusing only on those things which are relevant to multimodality. So, a question. How do we explain the cognitive resources? What we have in our mind that enables different kinds of human communication, since there are different kinds. And in particular, how does it help us understand the ways in which that mind helps to integrate all these very different ways of communicating during one online performance, right? So it's an extremely complicated task looked at from a processing point of view, and also about the representations that are involved, and the whole integration of this, millisecond by millisecond, is truly an amazing feat by the human mind. Well, the first answer, the most obvious answer for me anyway, and for my colleague John Truscott, who has been developing this over the years, this framework, is that we do need some kind of overarching cognitive framework, some theoretical framework which fits in with current trends in cognitive science and which integrates them into some form of basic framework. So not a grand theory of the mind, of course, but something proglometer to that, a kind of first stage in the climb towards such a wonderful ideal, a framework within what such explanations can be explored together systematically, and this means that you can talk about, human emotions, and you can go to what psychologists say about human emotion. You can look at the research in neuroscience on human emotion, and then you could develop some kind of account of human emotion. But at some point, all these accounts have to be fitted into the mind as a whole, and for that you need such a framework. Okay, so the mind, or rather cognition. Cognition, of course, is the study of knowledge, and there are many different perspectives from which we can study knowledge. I'm mostly interested in two of them, and the first one is the neuroscientific perspective, so looking at the brain, and the second one is the psychological perspective. And if you ask a question, what is the brain? No one will be surprised that the brain is a highly complex physical object. Its activity taking place in time and in three-dimensional space, and it's accessible, right? You can image it, you can describe it, you can do all sorts of things, you can dissect it if it's dead, and we have all sorts of means by which we can look at the brain, the physical brain, and explore its anatomy and its physiology. What then is the mind? Well, it's not the brain, but the mind does reflect what much of the brain does. I say much of the brain because when we're talking about the mind, we're probably not dealing about the whole brain, the whole central nervous system, but more or less the cerebellum, the cerebrum, not the cerebellum, the cerebrum, much of what the cerebrum does, but at a much more abstract level of description, and that is the psychological level. So activity in many areas and pathways in the brain may be seen as physical manifestations of what the mind does. So from an MCF standpoint, mind and brain are related. In fact, they will both be related as closely related, distinct but closely related biological phenomena. And it may seem strange to talk about the mind as biological, but obviously you can see that if they're closely related and the brain is a biological phenomenon, therefore the mind is as well. So the question is, what's the difference? The difference is simply the level of explanation and description. And this will be demonstrated further. And this also raises the problem of mapping. How do we map brain functions onto psychological functions, cognitive functions? How do we map the mind onto the brain? Clearly the relationship is not going to be an easy one, it's going to be a complicated one, and this is the mapping problem which has intrigued many people over the years, and there's a nice article by Popel in 2012 precisely on this subject. So we have extremely detailed maps of the brain, but do we have anything like corresponding maps of the mind? There's a question for you. At both levels, anyway, we are talking about a network, and we're talking about a network composed of interacting, collaborating if you like, specialized knowledge systems, and this is going to be dealt with in a little more detail in a minute. But in many areas of science we can in fact keep levels apart, and it's useful to do so and develop our own approaches to the things that we're interested in. And depending on your interests, it's possible to confine discussions exclusively to brain matters, clearly, neuroscientists do. Alternatively, if you're a psychologist, you can talk only about the mind and never shed even a syllable on time on what the neurons are doing. But when it comes to cognition, it's very difficult not to mix levels. It's almost inevitable, in fact, especially when you are a neuroscientist talking about neurocognition, to discuss the mind and brain features at the same time. Here are two examples taken at random off the net, by the way. The amygdala, everything in red has to do with neurons or with the brain. The amygdala is what helps us to respond to emotions, including anger, fear, sadness, in order to protect us. The amygdala also retains memories of emotions experienced and when they occurred. Now you see, at one point we're talking about the brain, and at another point we're talking about the mind, and we're mixing them together in a single explanation, even though we have very, very much more detailed maps of the brain than we do of the mind. Second example, again taken at random, from tamethebrain.org. The rational brain, prefrontal cortex, is the seat of executive function, rational thought and judgment. Right, here we are, a bit of neural hardware in red, together with the psychological software marked in green. Okay, let's now look at the psychological side, that is, abstracting away from all the intricate neurological details, and let's look at each of the mind's specialized systems. What do they have? They have the same basic design. So at this level of abstraction we can at least begin in simple terms, right? So each of these mind specialized systems that I'm going to be talking about those ones that are to do with multimodal cognition, one processor and one store, right? If you want to talk about the brain, of course, the processing resource is certainly spread across different areas of the brain, different pathways, and the store perhaps less so, but that is another matter for the red area, the red people. I'm a green person right now, and we're staying with green, we're staying with the psychological level of description. So there's a processor and a store, and if you want to know what those little yellow marks are, they are structures which we often refer to as representations. So what the processor does is it creates and manages representations using its special processing principles. Right? So each processor has a unique task, a unique function, and it does it very efficiently using its own processing principles. It doesn't have to borrow from some general store. And by the same token, it stores its representations, what it builds over the lifetime as you experience more of the world. It builds these special representations in its store. And if you look at the representations, they're all structured, they're all constructed in a special way which mark them out as belonging to this particular store. Here's an example, right? Let's take audition. This is one of the modalities we're going to be talking about. The auditory system is it has a store which has representations, those little yellow circles you saw, and these are creations of the auditory system. Creations of the auditory system. The auditory processor has done this, and the original impetus was given by acoustic input from our soundscape, our immediate soundscape. So our lifetime experience of sound, the sounds around us, is, as it were, picked up and processed and becomes a particular pattern which we can then restore. So if you hear a particular kind of sound, you can develop a representation of it, and that representation can then be activated anytime you like, when you hear it again, or when you don't hear it again, but when you think about it, when you dream about it, and you can regard it also, if you like, as a memory. So, to repeat what we said before, the auditory processor creates and manages auditory representations using auditory principles, and it stores its auditory representations all here conforming to those auditory principles, right? So that means a representation of some kind of sound, some pattern of acoustic, raw acoustic input that has been stored and processed as the system has constructed an auditory representation of that particular sound, and it's sitting there in the auditory store. And because this is a specifically human auditory processor, it will be different from any equivalent response from an animal like a cat or a dog or a lion or an elephant or indeed a great ape. It will be different from that, but it will also be different from a visual representation in your head, where you have been processing a visual input via your eyes. So it will be quite distinct in many ways. So we can ignore acoustic input, the physical acoustic input, which is impacting on the brain, but we can talk simply about cognition at this level of description, and it begins with systems like this, right? In the case, auditory cognition begins with the auditory system, and we can't leave that alone without pointing out that this auditory system doesn't float around in a vacuum. You know, it's not kind of completely cut off from the outside world. It is connected up multiply, very often, with other systems, and the way it's connected up is using these interfaces, these connecting pathways that will allow interactions between the systems, and I'm going to talk about that now. Okay, let's take that auditory store again, and let's take a particular auditory representation. There it is, the yellow circle with the A in. It's an auditory structure, and that has been developed as a result of acoustic experience that this individual has processed, and there it is sitting in the auditory store. And here is the visual store, and here is an equivalent representation here, something which is a visual representation built up because of visual experience. And I'd like to point out that these two representations can't be linked. They can be linked together, but they can't be pushed together into one huge representation. They can only interact by forming an association, and the association can then lead them to be co-activated, and this all happens via that interface. This happens to be the auditory visual interface, right? This is the way that these two particular systems are connected up in the grand network that is the mind. And just to mention in passing, association and activation are always a matter of degree, so things can be strongly or weakly activated, they can be strongly or weakly associated. Okay, now let's have a look at three systems and the stores of three systems. And we've got here the auditory and visual store again, but I've added a conceptual store. The conceptual store is going to assume a great importance for the rest of this discussion. And what is the conceptual store? It is a store in which we process, construct, process, activate meanings. So its area of expertise is our abstract meanings. And there's growing evidence, I think, this is still a matter for some controversy in neuroscience, but there is certainly some growing evidence for an independent conceptual system which is amodal and independent in the brain. So this does seem to have a direct equivalent. Okay, so we got three different representations here. We'll put them in, and they will form a small schema. So let's build this schema. Let's have a conceptual representation, a meaning, if you like, and let's have a visual representation, something which, when activated, will create a visual experience in your mind. And let's have one of those auditory representations, which, when activated, will help you produce or recognize a particular sound. And this is, of course, connected with a conceptual, so it can be associated with a meaning. Okay, there's the meaning. There's a mental image that will happen when you activate it, and that'll have the meaning. Now, the meaning you see there is the sound is associated with the meaning of firework, and the visual image, the visual representation is associated with the conceptual representation firework, and the associations run around in a threesome, and that's a small schema, and that's to say a schema. A schema is just a set of associations which are, as it were, which have been established during your lifetime. And let's have the visual image will be something we might call a flash, although it won't be labelled as such in the store. It'll only be it's only a flash because it's linked to something, a meaning in a conceptual store, and bang. And once we've activated that schema, we have an activated schema of representations. They're all activated in parallel, and to a greater or lesser extent. So that's how it works. So this network of interconnected systems, how is it organized, right? We know already that the individual systems are linked by interfaces, but let's now talk about the two rings, right? The two rings to rule them all, as it were. So there's an inner ring and an outer ring of systems, and it's convenient to look at it that way. The outer ring, which we mark in blue, the inner ring, which we mark in red. The outer ring is the one that the closest, as it were, connection that the mind has with the world outside, and it's the perceptual ring. right? And it contains the perceptual systems, and we saw two of them. We saw the auditory system and the visual system. There are other ones, of course, and they each build specialist knowledge from input received by one or other of the five senses. We saw, our example earlier on was acoustic input. So there they are. We won't be talking about all of them really in detail, but we will be focusing on the auditory system. And notice that at least 4 of these sensory perceptual systems could be used in multimodal communication, although we'll only be looking at the visual and auditory systems. Right, the visual and auditory systems there, we could, for example, use touch, which is part of the somatosensory sense. We could possibly use smell in order to communicate. I can imagine we could even use taste. So, the inner ring. Now, all we've got now, up to now, is a whole set of stores which contain the results of the processing of sensory input. So, sensory representations of 5 different types. But they have to be linked up with an inner ring system in order for more complicated processing to take place. And one of these 3 that I'm going to mention right away, with its multiple connections, is particularly important in the present context. I've already mentioned it, so you may guess what it is. But I'll mention the other 2 before dismissing them. Of course, the motor system is important because when we are trying to communicate, we need the motor system to be able to gesture, to be able to make a facial expression, or indeed to speak and write and convey a meaning via sign language. We need that. We also need that for others to have at their disposal so that we can decipher what they are communicating to us. Right? So that will be put aside for now. And there's the affective system, which is extraordinarily important and underrated, I think, in many research areas. The affective system is not only, in the MCF at least, is not only an affective system, it's an appraisal system as well. So not only the basic emotions are processed via the affective system, but also positive and negative values. So an affective representation like a positive, for example, if it's associated with a taste, then that taste will have a positive value for it, and you will tend to be attracted to it. If it turns out that it's a toxic, nasty taste of some kind, then it will have a negative value attached to it. So you get a sense of what the affective system does, but we're going to throw that one away, and we're going to concentrate on the number 1, which is the conceptual system that I've already talked about. So, to summarize, the conceptual system handles all meaning representations, right? And now I just have to mention resting levels and working memory, right? So existing representations in any store will all at any given moment have a particular resting level of activation. There is, well, we've got a blue representation there, happily sleeping away, so not activated, sleeping, dormant, or if you like, resting. And in any store, when things aren't active, then you will have a lot of representations all in this state, but they will be resting at a particular level. And these levels can change over time, but there we have a situation with a particular level, and representation at different resting levels stay like that until they're activated, right? Which brings us straight on to the notion of working memory. And there are, if you look at the working memory, if you use the concept of working memory in your research, you really should know that there are more than one versions, more than one approaches to what working memory is, and the MCF takes a particular one, right? So when a representation is activated within its system, it enters into a temporary state called that system's working memory. So you see that working memory isn't we don't need another box for it. It's not a buffer. It's not somewhere else, as it is in some approaches. It's simply a state. It's a state of activation. That blue kind of sleepy representation doing nothing. Once it is called into action, once it's activated for potential participation in a particular task that the mind is engaged on, it is automatically in working memory. In fact, it's in that system's working memory. So there's an auditory working memory, a visual working memory, a conceptual working memory, an affective working memory. And all that means is, if you've taken as a whole, if something is in working memory, that means that all the relevant systems that have been brought into action have certain of their representations in a state of activation, and collectively that's all can be referred to as working memory. In fact, the working memory is something that happens within a particular system. But of course, since all systems many systems are collaborating at the same time, they will all have their contribution to the totality of working memory. Right, so this is where we have to use a metaphor to explain it, and let's use the metaphor of altitude, by far the best one, because we've already done it actually by using the word level. So there are those representations. Most of them are still happily sitting in their particular resting level, but we're going to activate 3 of them. So let's wake them up. And there they are, and we can imagine them figuratively as rising from their resting levels into a state, this sort of yellow state of working memory. And they are there, they activated from their current resting levels, and while they're there, what the processor does, it tries to put them into some coherent order in terms of its particular processing principles. So if you're a linguist, you can easily understand it by saying, imagine these are syntactic representations, they're nouns and verbs and what have you, and these particular ones have been activated for some reason. The processor simply has a job concentrating only on making some coherent sense of them, putting them together in a larger sort of representation, like a noun phrase or a sentence or etc. How does growth and development take place? Well, the longer term of activation is such that after any representation is activated, it will return to a slightly higher, more accessible resting level. Let's just see that again. So it comes down, it's no longer needed, but the effect of activation is to raise its resting level. So the more you use it, as it were, the higher it becomes in our metaphor of altitude, and the closer distance it has to working memory. So it will be more and more accessible the higher it is, all other things being equal. Now, it should be clear to anyone, if they didn't know it already, that if lots of representations are being activated, there's always the possibility that they might compete, and indeed they do compete, and that is a standard situation. Not all representations that are activated will get used in the current task. So activation is profligate, that's to say, many get activated, not all will get used. It's the law of the jungle, in other words. So online processing always involves ongoing competition between representations. And here are 5 that have been activated. Some of them don't have any relation with one another, but those that do will be competing, as it were, for participation in some current task that the mind is dealing with. And it's activated lots of things, hoping that, as it were, figuratively, that it can use some of them. And of course, once these are activated, the processor in that particular system is trying to make sense of them, put them into some order. But at a certain point, two of them will not be used, and their activation will be curtailed, and so they will certainly benefit from the brief period of activation that they've had. They will go down to their slightly higher resting level, but these ones which have actually taken part in the task will be there a little longer, so they'll benefit from that. So yes, as I said, it's an over-generating system. Activation is always highly profligate, but it turns out to be it pays to be over-generous. So all other things being equal, the higher a representation's resting level, the more competitive, i.e. the more accessible it is. And according to our acquisition by processing theory, this is what happens when things are, let's say, acquired, when things get more available, and when things become less available, and we start being unable to access them altogether sometimes, and we call that forgetting. So the process is that association is formed, and an association grows stronger as resting levels rise, given regular repeated activation. If you don't get the regular repeated activation, then the resting levels will not rise, and they will tend to sink very subtly and gently down towards the bottom, right? So you use it or lose it, as it were. Okay, now let's turn to some examples of multimodal communication, in which I will try and develop some schema to show you exactly how that works and how it will be translated into terms of the MCF. So humans can communicate messages to each other using a variety of means and modalities that we have seen. For example, they may use gesture, including facial ones, facial expressions. They may use touch, and they might, for example, use non-verbal vocalization. Non-verbal vocalization simply means, making sounds, using your vocal tract, but not actually producing words. So, in other words, non-verbal. And then you have speech, which does result in verbal vocalizations, and you have text that you can read, and you have, of course, sign language. And you can guess, perhaps, immediately that the top three are non-verbal and the bottom ones are very much verbal. So all of these means can be used either singly, which is rather rare, or in combinations, which is very frequent. Now let's look at primates for a bit. Now, three of these resources, obviously the non-verbal ones that I mentioned, happen to involve resources that are shared with other species. I'm thinking now of species close to us on the evolutionary ladder. In fact, a species that is closest to us, the chimpanzee, including the bonobo. So according to Hobeiter and Byrne, these are primatologists. Kat Hobeiter works in Scotland when she's not looking after chimpanzees somewhere else, in St Andrews University. And Hobeiter and Byrne produced a very nice research article in 2014 where they reported a study of uninstructed chimpanzees. I put uninstructed there because there have been a number of attempts to instruct chimpanzees in a way of communicating with humans. So this is a different situation. They're uninstructed, untutored chimpanzees in their natural environment, right, not in a laboratory. And it turns out that they have a repertoire of 66 distinct gestures. And these 66 gestures are used to communicate meaning, to intentionally communicate meaning. How many meanings Well, they distinguished 19 different meanings, as it were. It's difficult to call this a vocabulary, but 19 different messages can be communicated by these means, using any one or other of these 16 gestures. And the kind of examples they give are stop that, move away, follow me. These are the kinds of meanings they're talking about. Interestingly enough, there was another study some years later, in 2019, in which Kersken and associates, including Holbeiter, when there was an overlap in 46 gestures, when they took those gestures that had been studied earlier and they compared it with the gestures made by 1 to 2 year olds, humans, that is, engaging in natural communication with their peers and with their caregivers. So they kind of reproduced a kind of study looking at humans in their natural environment, but of course humans that hadn't yet developed language, but were relying completely on communicating with gestures. And to their surprise, I imagine, 46 of those 52 turned out to be the same gestures that the chimpanzees were making. So this has an evolutionary dimension, and we can see that gestures, communicating by gestures, is very deeply rooted in our DNA, and that might give some support for those people who think that it's gestures and not sounds that were the beginning of the development of what would turn out to be human language. Okay, so gesture is deeply embedded in natural chimpanzees' communicative behavior. This also goes for communications amongst humans and continues alongside language. So this continues alongside language. Now the question is, what makes the three language-based, those verbal-based uses of auditory or visual modalities unique to humans? And the answer is, of course, linguistic structure. And linguistic structure is run by two inner ring systems, in the MCF at least, two inner ring systems that I didn't mention before. I only mentioned three then. And these systems are the phonological system and the syntactic system. And these are uniquely there to build two types of linguistic structure. And this precisely provides us with an extra support which is not shared with other species. What is the external impact of this? The evolution of this linguistic ability delivered by these two structural systems. Some people would say there's only one grammatical syntactic system. That's possible, but at the moment we'll stick with the two. So the impact is that complex meanings gets built and stored as representations in the human conceptual system. That's right. So using the resource that we have with linguistic structure, we can construct many more meanings and more complex meanings. So in effect, linguistic structure has facilitated a major enhancement of human conceptual abilities. So you might say it has enriched human multimodal communication seen in the large. Now these two systems, we should stress, they work blindly, right? They just build structure, two types of structure, and they activate these structures, and they do it blindly for any language. So if you're a monolingual, obviously it'll only do it for your language, your single language. But if, like many of us, you have another language at your disposal to some extent, it will do it for that. So you don't need any labels in these two systems to identify them as language. They just put together things in the processor puts together things just in an order according to its phonological or syntactic rules. So effectively, multilinguals, bilinguals, trilinguals, multilinguals construct different associative schemas. Remember the schemas we saw? We built a schema, a little schema. These will be more complicated, of course, involving more systems and more representations. Multilinguals construct different associative schemas using exactly the same two linguistic systems. And here they are. There's a syntactic system, there's a phonological system. They're interfaced together, of course, as you can imagine, and they form a network like this, right? So this network provides is the vehicle for building linguistically supported schema in the course of communication. You might see I've linked up the phonological system with the visual system, which might seem strange given the etymology of phonological. Phonos, of course, means sound, but it seems that what we have always called the phonological system, because of its association with speech, can also be adapted to use other modalities, the visual modality as well. It's difficult to see an olfactory language or a touch language. Well, there is of course Braille, but the other systems are, because of how they are in humans, are less well adapted for a complicated linguistic system to develop. So the auditory and visual systems are the ones that humans use. Okay, I mentioned the schema. Let's now build what you might call a verbal schema, a schema using linguistic structure, right? And only two modalities. So, okay, at any particular moment, maybe a noun count, which will be a representation in the syntactic system, will be represented. It'll be activated, and it'll be activated in parallel with something that is associated with in the conceptual system, namely the padlock meaning. Well, it may be more, but okay, let's say the meaning of padlock. At the same time, because of the prior experience, it will have been associated with the phonological structure. I've used the traditional phonological conventions there. Padlock. Padlock is then this representation, a complex representation, has been activated at the same time because of its prior association. It belongs to the schema. Or if it's a question of sign language, the signed version of that, right? At the same time, the auditory system has produced an auditory representation of a sound, and that auditory representation is triggered when the sound padlock is heard, or if you're the one who's doing the communicating, of course, thanks to that motor system, you're able to articulate a particular pattern which is triggered by the auditory system, and that particular pattern is the sound padlock. The visual system can also be used, of course, when you see the visual pattern PADLOCK, as we know it is. That will also be part of the schema, because it will be linked to a visual representation, and that will be linked up with the rest of the schema. So all of this happens all at once in parallel, and that instant sort of complicated schema, once it's activated, will okay, let's say you are listening. The moment that sound is produced, bang, into your head comes the meaning of padlock. All the rest of it is subconscious. And not to forget sign language. If you see the sign, padlock, the padlock sign, the same thing happens exactly as I've described it. Okay, so linguistic structures are needed to communicate complex messages efficiently, but they are not indispensable for communication to take place, and we need to have a look at non-verbal schemas, right? Now, thanks to the evolution of the human conceptual system, as I said before, degrees of complexity in non-linguistic communication can be achieved that may exceed even the impressive abilities of tutored chimpanzees, instructed chimpanzees. Right? And instructed chimpanzee, I mean the famous kanzi. I don't know if you know about kanzi, but if you Google kanzi, K-A-N-Z-I, if you Google kanzi, you will see that's amazing performance by that bonobo being tutored to produce many different messages, often with small combinations. But none of those meanings will have any degree of complexity that matches what humans can do. Savage Rambo-Levin is the one who is most associated with this research. And in addition, something I haven't really referred to and won't go into in great detail because I've done that elsewhere, at very high levels of activation, conceptual structures will also support conscious thinking. So once your conceptual structures are very activated very highly, then you get this thinking happening, and during that thinking and when you're communicating, you will be able, this is sort of an additional resource, you will be able to think about what you're doing, and you will be able to some extent use a smart strategy to control the various things that you're using in order to get your meaning across in that particular context. And in multilinguals, meaning may also be conveyed using more than one language. I talked about code switching in another presentation. So we can switch from one language to the other, we know that, and then they also compete with one another. But at the same time as we're doing that, as we're code switching, we're also using these other methods. So you might say these gestures and things must be surely sort of side issues. They're used to perhaps emphasize, go with your speech, link up with some boundaries in the phonology and syntactic boundaries. You see people gesturing, so I'm like this, I'm trying to make my point as much as possible. You could think of these totally as compensatory strategies, so that when, for example, you find yourself being disfluent and inexplicit when you use language, then you can bring in various other means that you have at your disposal, non-verbal means, to back up and emphasize or clarify what you're doing. But this is not really a very fair picture of what these non-verbal means of communication do by any means. But at least if you are, say, a second language learner who hasn't really become very fluent in the language, then you can indeed gesture, point, do all those other things more, and research seems to show that these people, in particular L2 learners, do this, whereas people who are not L2 learners but have a full command of language or the languages, funnily enough, they don't use these compensatory strategies so much. That's what the research seems to show. So what we should add is that many of these non-linguistic resources are frequently deployed to supplement or complement the information being conveyed by language. So language in that case is not conveying quite enough for the full message to be transferred to the other person who's listening or reading. So these other non-verbal means add referential and pragmatic information to what is currently being conveyed. So this complementary adding function of non-verbal communication is very much what current researchers in multimodality are stressing. Okay, so communication using conceptual roles. Here are some examples. where let's say we can confine ourselves just to without actually directly using language, we can do quite a lot of things with these various means. Now, basic variety, you might find that a little controversial, but in principle I think Klein and Purdue's notion of basic variety, which is a basic variety which springs up between people who, well, for example, migrant workers in a foreign country, where they're trying to communicate with one another using words they've learned from the host language, but putting them together in a way which is not in conformity with either the syntax of their own language or the host language, use a kind of set of I'll get to this in a minute, conceptual roles to actually communicate quite a lot with words, right? Home signing is when people develop their own proto sign language, not really a sign language, but they manage to develop some way of communicating and using gestures with someone who in their group, which is not is not able to understand speech, and this happens before they've actually acquired a sign language. Baby signing is just another way of doing it that parents use to talk, as it were, to communicate with their children before the children have started to acquire language. Foreigner signing is perhaps much more usual. That's when you're talking to a foreigner, trying to tell them something, trying to transfer information to them, but you have no language in common, so you use gestures and signs of various kinds. And it's surprising actually how much information you can get across just in that way. You can use non-verbal vocalizations, you can use pointing, you can use touching. Pointing, for example, is only something that humans do, which is interesting. It's a human-specific gesture. So in other words, much non-verbal communication is possible. And the vital component is the conceptual system. However, having said that, it's as though that when we're talking, when we're communicating non-verbally, it's as though the language systems are switched off. That is not at all the case. Language systems, the linguistic systems, the linguistic structural systems, the two that we mentioned, the syntax and phonology, these are always active and they're always connected up with their conceptual system. So although you may not actually be using language directly in the non-verbal exchanges, linguistic structures that are associated with them will still be regularly co-activated along with the associated meanings, and that will always be happening thanks to the conceptual system. So you'll have that sort of in the background. Okay, let's now look at a non-verbal schema. So we had padlock before. We have the concept padlock being activated, and indeed it can produce a sound, which is not a word, but it could be a sound suggesting a padlock. I don't know what that would be. I can't think offhand, but I can certainly imagine someone mimicking the shape of a padlock, or pointing, using pointing to point to something in the environment which looks like a padlock or is a padlock. There might be a visual image of a padlock nearby, or an actual padlock that can be pointed to, or you could perhaps draw a padlock in the sand, something like that. So this is how padlock will be communicated without the direct use of language. Remembering all the time that the language systems are buzzing away in the background. So this is a non-verbal schema, right? Again, using only the auditory and visual modalities. Okay, so I've given you two examples, a verbal and a non-verbal schema. I think it's quite interesting to know where it all begins. And I thought I'd take a little aside, not strictly related to multimodality in particular, But if you think in terms of the auditory system and the visual system and the conceptual system and the other two, the two linguistic structural systems that we are talking about, what do they look like when you start off life, right? So in the MCF, prior to any experience, all knowledge systems run in the same way. Including those for multimodal communication, they begin life in the same way. And what they don't do is they don't start life as a blank slate. So they're not empty. This is prior to any experience. You're strictly at birth. The first experience you have, you don't come into life with a blank slate in any of these various cognitive systems. Every system has what I call a biological starter set. And what does it contain? It contains what you could be called primitives. Primitives are special building blocks already there for constructing new representations. So your first sound, the first thing you see, the moment your mind starts building a representation with it, it must be able to do it in a typically human way, and it does that because it already has certain things ready-made to do the job. So it would include preset associations within a system. So in other words, complex representations in the system linked together already. So I have two examples here, one for linguists. So a basic face shape, right? So children orient instinctively towards face shapes. So there must be some kind of complex visual representation there already, which is a face shape, right? Linguistic example, a specific one, is Vestergaard's notion of what universal grammar is, namely microcues, composed of microcues, and these again are small bits of structure, so not simple just things like noun, but things put together already available to us the moment we start acquiring language. And there are also in the starter set what I might call schemas where there are links not only within the store but across to other systems, right? And an example of this would be the baby's instinctive parachute reflex. What is that? That's when a baby is jerked forward, and the baby will spread out its arms as if to catch itself. This is a instinctive response. It's there at birth, and it means that there is some kind of connection between the somatosensory system, which is the one where you have a sense of your body movement, and a particular motor response to throw out your arms. So it'll be a complex representation within the somatosensory system, plus a complex association already in the motor system, and these will be already there as a schema. So, and of course for different species there will be different ones, or some of them may be shared, of course. And then there's a schema, another example with I mentioned that pointing was unique to humans. So a pointing gesture where you have you want to direct someone's attention, so you point. The point, of course, is controlled by the motor system, but it's there for a reason, so it must be a schema with another system. It develops about 11 months, and of course it's shaped by culture and is, as I said, unique to humans. So different cultures may well point in different ways. Very often manual pointing is used with the fingers or the arms, but you can use your head movements, or you can use your lower lip, for example. And then another example will be facial representations pre-linked to a positive value in the affective system. So recognizing a smile for example, suggests there is a starter set, link, a schema which can explain this particular instinctive response. And now we come to the final conclusion, and I'm going to draw, as I said, some implications, in fact 7. So the first one is to explain multimodality, what we require is more than just a rough idea of how the mind works to match up against the complicated maps that we are offered by the neuroscientists. We need a full set of cognitive functions supported by a cognitive architecture of the mind with a sufficient degree of detail before we can tackle that mapping problem. So that cognitive functions in multimodal communication can then be systematically aligned with their neural manifestations. But I think that is a long way away from now. So the second implication is that all aspects of human communication depend first and foremost on that central cognitive hub that we call the conceptual system. And thirdly, that the use of linguistic structure appears to be the only truly qualitative means of distinguishing human communication from that of our nearest relatives. So the verbal means that we have at our disposal are something special. I'm going to qualify that in a minute, but let's move on to point 4, which is a quantitative one, and it says that compared with other species, non-verbal multimodal communication at least looks quantitatively different, right? So that means we have more meanings to convey. The effect of linguistic systems developing alongside the conceptual system over evolutionary time, of course, has led to an enhancement of the human conceptual system. And that means that we can construct many more meanings, and many more compared with that of our clever fellow primates. 5. These meanings do not only differ quantitatively, but they are more complex. So humans are already able to construct and express more complex meanings as well, which could be counted as a further qualitative difference between us humans and our fellow primates. And 6, conceptual roles. Right, I mentioned them briefly before. Complex meanings can be put to use in non-verbal multimodal communication, and that means that you can have a sequence of meanings organized with signs, gestures and vocalizations, which you could argue that chimpanzees can manage, also in combinations, as we see from the research carried out by Savage Rambor and others. But in our case, we can use these conceptual roles that we have in our conceptual system, like agent, actor, patient and path, and we can, as it were, create a kind of supporting conceptual grammar, you might call it, to organize these complex meanings that we have available to communicate, and still not directly use language. Nevertheless, we can't rule language out at all, because it always supplies what I call covert support. So during non-verbal multimodal communication, an individual's linguistic systems will still inevitably get activated. Right? They get co-activated because they've got this link with the meaning systems that are being activated. So co-activated linguistic structures active during any non-verbal exchange thus provide ongoing covert support in the management of the information being conveyed. So although you're not actually expressing the syntax and phonology that you have at your disposal in your non-verbal communication, at least not directly. It is there, and it is acting as a sort of background support. So in other words, all the various types and combinations of non-verbal multimodal communication between humans can be and are being studied systematically. They're being studied systematically, and they can be studied applying MCF architecture. Why? Because this can reveal in some detail the ways in which the mind achieves an integration in real time of all verbal and non-verbal means. So that's one of the things that this architecture can do, and it can do so according to its general cognitive processing principles. Right. So although each system by itself is separate, they have all conform to these general cognitive processing principles. And that brings me to the end of this presentation, which has been quite long. And on the left you see humans communicating, and on the right fellow primates, chimpanzees, also communicating. All of them are using gesture. Only one group are probably using linguistic structure directly, and if they're not using it directly, they'll be using it indirectly. And at the bottom you can notice the URL, which was the URL of the Cognition Framework.com. Go to the multimedia page, and not only will you see this particular presentation, you'll see lots more. So this is where I sign off, Mike Sharwood Smith, saying goodbye for the time being.